In this lesson, we're going to learn the difference between an independent and a dependent variable. So an independent variable is the x value or the input, and it stands alone. What I mean by that is that it isn't affected by the other variable. If one of your variables is time, it will always be the independent variable because time doesn't depend on anything else. It keeps ticking at a steady pace. So the dependent value or variable is the y value, and its outcome, it's the output of the function, and it depends on the x value. So for example, if you were thinking about the rate of change miles per hour, remember when we calculate rate of change, it's change in y over change in x. So the miles per hour. The amount of miles you travel depends on how long you've been driving. Rate of change, today we're going to take a look at whether rate of change is positive. Both variables increase together. For example, miles per hour. The longer you drive, the more miles you drive. That would be a positive rate of change. Negative, one variable increases and the other decreases. Or zero, the dependent variable does not change. And we'll look at some examples of those in a minute. First, we're going to practice identifying the dependent and the independent variables. And our essential question today is, what is the difference between an independent and a dependent variable? So one way that you could try and figure out which is the independent and which is the dependent, if time isn't an option, is looking at step one. So let's look at our first example. We've got 2 pounds of apples costing $3 and 6 pounds costing $9. Nowhere in there did I say time or minutes or hours or seconds or days. So we're going to follow step one. To figure out what the two variables are, you find the numbers, and it's the label that's associated with that number. So 2 pounds is one variable of apples cost $3 is our second variable. So does the pounds of apples we buy depend on how much we pay? Or does how much we pay depend on how many pounds we buy? Hopefully that second sentence made sense to you. So then we've got our dependent variable figured out because the cost depends on the pounds. So our independent variable is the pounds, and our dependent variable is the cost, or the dollars. So if you write independent then dependent variables, you'll have them in x, y order. X is your independent, y is your dependent. So to calculate the rate of change, remember, we're going to do change in y over change in x. So the change in our cost from $3 to $9 is an increase of $6. And the change in our pounds, 2 pounds to 6 pounds, is an increase of $4. So we're going to simplify this. And typically I would tell you to leave slope as an improper fraction. But here we're talking about, if we label our answers, cost per pound. So it doesn't make sense. You don't go to the grocery store and see a sign on the apples that say 3/2 of a dollar per pound. So we're going to convert this into a decimal. Hopefully you remember 3/2 is 1.5, or $1.50 if we're talking about money. $1.50 per pound is our rate of change. Let's take a look at another one. Reading through this one, we have an airplane ascended 3,000 feet. So we hit the number and then we circle the label that's associated with it in 10 minutes. We get to skip step one on this one because we have a time, and that's automatically our independent variable. So our dependent variable is the feet. We've got this in x, y order. We have to flip it around though for a change in y over change in x. So looking at our change in feet, we went from 3,000 to 4,500, so that's 1,500 feet that it increased. And then we went from 10 minutes to 15 minutes, so that was an increase of 5 minutes. So we're going to simplify this. 5 goes into 15 3 times, and 5 goes into each of the zeros 0 times. And labeling our rate of change, feet per minute. So on average, the plane rose 300 feet per minute. One more. In January, the Johnson's heating bill was $100. And in April, it was $50. Okay. Well, I only saw one number on this one. What's our other variable? What else in this question changed? Well, the Johnsons didn't change, the heating bill didn't change. What changed was the time. We went from January to April. We've got time, so that's our independent variable. This time our time is in months. And our dependent variable, the cost of the heating bill, depends on what month it is. Okay, so there's our XY, change in Y over change in X. So the change in cost, it went from $100 down to $50, so that is a negative 50 that it changed. And then the change in months, well, from January to April is 4 months. So we are going to simplify this to negative 25 halves. But again, we're talking about cost per month, so it doesn't make sense to say that our heating bill changed at negative 25 halves per month. Well, 2 goes into 25 12 times, with 1 left over. Sorry, I can't talk and think at the same time. So the heating bill decreased on average $12.50 per month.